Hello guys, welcome back to VC Tech. You already know how IPv4 works. You know how to configure IP addresses, routing, and basic networking. But here's the problem. IPv4 is running out. And that's exactly why IPv6 exists. In today's video, I will explain what IPv6 is, why we need it in today's network, how IPv6 addressing works, and why IPv6 is no longer optional in modern IT environments. If you're studying networking, cybersecurity, or enterprise infrastructure, IPv6 is something you must understand. So let's talk about what IPv6 is. IPv6 stands for Internet Protocol version 6. It is the successor to IPv4, and it is designed to replace IPv4 due to address exhaustion. IPv6 also uses 128-bit addressing compared to IPv4 that uses just 32 bits. IPv6 wasn't created to improve IPv4. However, it was created to replace IPv4. And why is IPv6 needed now? Because IPv4 has a limited number of addresses. It uses NAT to prevent the exhaustion of those private IP addresses that they have, as NAT is only a temporal workaround to IPv4. Growth of cloud computing, IoT devices, mobile networks, and 5G infrastructure consume a lot of private IP address, which is IPv4 addresses. IPv6 allows through end-to-end connectivity. With IPv6, every device can have its own unique IP address. There will be no need for NAT, no translation, and also no complexity. The benefits of IPv6 include massive address space. As you know, it has 128 bits, so it means there will be a lot of IPv6 address out there. No NAT required, so there will be no need for public and private IP address, as the IP address that you have, the GUA IP address that you have, it's routable outside your own network. It also simplified packet header for faster routing. IPv6 also comes with a built-in IPsec support, as it is better for scalability and also mobility. IPv6 also enables efficient multicast instead of broadcast. And lastly, IPv6 address type and how they work. Global Unicast Address, which is the GUA, is publicly routable on the internet. It is similar to a public IPv4 addresses, and typically it is assigned by ISP or enterprise. While we have the link local address, the link local address always starts with FE80 : whatever number you want to use, and it is automatically generated. It is used for neighbor discovery, routing protocols, and it is not routable beyond the local link. So with that being said, let's head over to our configuration, where we'll be using one router for this tutorial, 2 switches, and 4 host devices. As you can see over here, we have our link local and also a global unicast address. I'm going to show you how link local and global unicast address, the effects of those in our network in today's configuration. So let's head over to the router and start with interface gig 0/0. Before we start the configuration on the interface gig 0/0, where we get to assign IPv6 address to it, we have to enable IPv6 unicast routing. This is to enable, or this is to let the router know that it is going to be using IPv6 instead of IPv4. So now the router is aware that we are going to be routing IPv6 address. Let's head over to the interface gig 0/0, and first let's say no shots. The first thing we want to do is to assign IPv6 link local address. So IPv6 link local address, this is how we configure that. then FE80 :1. After doing this, we have to specify that this is a link local address. By doing this, we've configured the link local address which the host devices, I mean these devices over here, could use to communicate within the local area network. Let's also create or assign the IPv6 Global Unicast address, IPv6 address, and we are going to be using this IP address or this IPv6 address over here for this tutorial, 2001.0bb9. Let's just type that here. So 2001:0bb9 :cdd :56788 and another :1/64. So by doing this, we've configured our link local address and also our global unicast address. Let's do that on the second router. Then we head over to the host devices and try to get IPv6 address. So for the second local area network, we want to say interface gig 0/1, no shots. We want to say IPv6 address FE80. If I'm not mistaken, for the previous interface we used 1. Okay, we used 1. For this we are going to be using 2, and we want to specify link local. IPv6 address, and this is where we configure the global unicast address. This will be taking 2002.0bb9 :TBD :8765 :1/64. By doing this, we've configured the same link local that we did on the interface gig 0/0 on interface gig 0/1. Now let's go and see something else. So on the host devices, we are going to try to get an IPv6 address. So I know you'll be wondering why we want to assign IPv6 address automatically to the host device when we did not configure DHCP. Well, there is something called stateless link local address. It is used to assign IP address automatically to the host devices. On the next video, we are going to be talking about DHCP v6, and you're going to see the difference. So if we click on automatic, as you can see, we have the same GUA that we created earlier, which is the global unicast address, and this is also the link local address. However, we don't have a DNS server because we've not configured DNS server, and we are going to do all that when configuring DHCP v6 in the next video. Now let's also head over to this device and try the same thing and see what we get. So automatic, and we get the same, and as you can see, IPv6 request was successful. Let's also head over to the second local area network and let's see what we are going to get. As you can also see, our IPv6 request was also successful, as it has a link local address of FE80 ::2. Let's try to ping the host devices. So from this device, let's ping the other network. So ping 2002.:bb9 :CBD :8765. We want to ping the default gateway. Oops, that's. So as you can see, we are able to ping the default gateway of the second local area network. This is how we configure IPv6 on a router, and also global unicast address and a link local address. And remember, a global unicast address is like a public address that devices in a local area network, these devices in the local area network, they use to communicate with this device on this local area network, because they cannot use link local address to communicate with this local area network. That's why we have what we call a global unicast address and also a link local address. Now, the link local address is used to communicate with device within the same network. I believe this video helped you understand how IPv6 is being configured on a router, and also how global unicast address and link local address help a network. If it helped you, why not subscribe to this channel, smash the like button, and I hope to see you in the next video where we'll be talking about DHCP v6. Thank you guys, and see you in the next.